Using Artificial Intelligence to Develop Software. By Mark McMullen. The software developed is trading algorithms for Bitcoin and other cryptocurrencies and disease control, specifically COVID-19. The AI improved the accuracy and effectiveness of the software, led to new discoveries, fixed broken algorithms, and saved years in development time. Background: Education. Mark McMullen attended university and spent years studying at home and online, resulting in the award of 4 university Bachelor of Science honors degrees. Science degree: Physics, Einstein's theory of relativity, quantum mechanics, cosmology. Technology degree: Electronics, microprocessors, digital communications, internet technologies. Computing degree: Software engineering, distributed systems architecture, network configuration, systems security. Information technology degree: Concurrent and distributed programming, artificial intelligence, robotics, AI dissertation. The AI dissertation compared fuzzy logic, a multi-layered perceptron, and a Koana network to detect and classify problems with large parallel, distributed software systems. Having detected and classified a problem, a knowledge-based system used backward chaining to diagnose the error and offer advice. The AI dissertation received the grade of distinction. Additionally, the following courses have been taken: Advanced Object-Oriented Programming, CUDA Multicore Programming, Parallel Programming, Machine Learning Programming, TensorFlow Neural Network Programming, Financial Engineering Programming, Algorithmic Trading, Cryptocurrency Investments. Mark scored 156 in a written, supervised test for Mensa, placing him in the top 1% of the population. 15 years, both permanent and freelance, as a software engineer, working on every aspect of software development including planning, architecture, design, programming, testing, and support. Notable employments include multi-threaded multi-process distributed programming for a workflow system at Hewlett-Packard in Reading, England. Time-critical programming for flight departure control at Amadeus and Heathrow Airport, London. High-resolution nanosecond profiling on an options pricing platform at Euronext New York Stock Exchange in Canary Wharf, London. Development of algorithms for post-trade settlement at Clearstream Deutsche Börse in Luxembourg.
The following presentation shows artificial intelligence known as AI, being used to develop computer software programs. The first program is a trading algorithm that uses the moving average cross strategy to trade bitcoins. The moving average cross strategy computes a daily buy average of the closing ask price to smooth out volatility. A second average is computed to give a buy signal. When the daily buy average crosses above the buy signal, it is time to buy bitcoins. Similarly, a third average is computed to give a daily sell average of the closing bid price, and a fourth average is computed to give a sell signal. When the daily sell average crosses below the sell signal, it is time to sell bitcoins. Thus, there are 4 parameters: buy average, buy signal, sell average, and sell signal. Finding the best value for each parameter is difficult because they are interdependent on each other. So, the value of each parameter has to be calculated in combination with the other 3 parameters. If a maximum of 50 days is specified for each parameter, then the total number of combinations is given by 50 multiplied by 50, multiplied by 50, multiplied by 50, which equals 6,250,000. The parameters for the moving average cross strategy used in the financial industry is typically 1 week and 2 weeks. So, to obtain an initial base reference, the first trial will use the buy average equal to 7, the buy signal equal to 14, the sell average equal to 7, and the sell signal equal to 14 for the parameters. A trading simulator program tests the trading strategy by running through real Bitcoin price data for every day of the last 2.5 years, calculating the averages and recording any trades that would have been made if it had been for real. The profit obtained was 171.86% for the first parameter set, 7, 14, 7, 14. Countless hours manually tweaking the parameters and rerunning the simulator resulted in a higher profit of 743.36% for the parameter set, 16, 26, 11.25. This manual work took 1 man-month, using experimental trial and error techniques. The 5 boxes on the left show what the AI system is doing. The combinations box shows the number of different parameter sets in each batch run. 1 simulation is ran for every parameter set. The simulations box shows the total number of simulations ran so far. Swaps is the number of times parameters are swapped between sets. Random changes is the number of times a parameter has been set to a new value. The 4 boxes on the right, buy average, buy signal, sell average, and sell signal show what parameter values the AI system is using to achieve a better profit. The evolved profit percentage box shows the best result so far. The display shows the parameter values that resulted in current best profit. For comparison, the graph also shows the profit obtained using the standard 1 and 2 week parameter values, and the profit achieved using manual methods. The AI has achieved a higher profit of 1092.58% for the parameter set 20, 22, 8, 23. It performed 19,933 simulations in 2 minutes and 7 seconds, 16 parameter swaps and 6 random changes. 19,933 simulations is much less than an exhaustive search of 6,250,000 fixed broken algorithms. The AI even managed to fix some cryptocurrencies from making a loss to making a profit. AI leading to new discoveries. For the cryptocurrencies that were fixed, the AI evolved parameters with values completely different from that of Bitcoin. Having the right answers, it was a simple task to go back and find the reasons. Examination of the price data showed the broken cryptocurrencies having volatilities that were completely different to that of Bitcoin. Saved years of development time. The AI ran 19,933 simulations in about 2 minutes versus 800 manually ran simulations in 1 month. The aim to develop 12 different strategies would take 1 year manually. To develop 12 strategies across the top 30 cryptocurrencies manually would take 30 years. However, it took the AI 1 hour and 20 minutes running in 30 parallel batches. COVID-19. Epidemiologists use the susceptible, infected and recovered (SIR) mathematical model to study epidemics. Organizations, such as the Center for Disease Control (CDC), publish statistics for the impact of different levels of preventives measures on the spread of COVID-19. Preventives measures include social distancing, travel restrictions, etc. A computer model comprising of the SIR equations and the CDC's statistics can be ran repeatedly by a computer simulation program to show the impact of the preventives measures on the spread of COVID-19 and the economy. The AI can run many simulations with different parameters to find the most effective levels of preventives measures to reduce spread of COVID-19 with the minimum impact on the economy. The model used has 10 different preventive measures and over 18 billion parameter combination possibilities. Further complicating matters, there are multiple goals and sub-goals. Top left are the country-specific settings such as population and normal economic growth. Demographic age groups with corresponding mortality rates. Top center are the COVID-19 settings such as recovery time and hospital duration. Top right, the AI information. Along the center, the plots show number of deaths for each age group, hospital beds and ICUs needed, R0, herd immunity and economy. Along the bottom are the parameters for the preventative measures, goals and sub-goals, and detailed results. The simulation was run with no measures and full lockdown to give maximum and minimum results. With no measures, hospitals are overwhelmed, and 2.82% of the population die. However, economic growth slows only slightly from 3% to 2.34% and herd immunity is achieved. With full lockdown, hospitals remain stable, and only 0.014% of the population die. However, the economy is destroyed at -56.54%. And herd immunity is not reached. The results of full lockdown and no measures are plotted as horizontal lines at the top and bottom of the graphs. A traffic light display of red and green circles represents the sub-goals, which are 25%, 50% and 75% of the difference between the maximums and minimums given by no measures and full lockdown. The AI's solution reduced deaths from 2.82% to 1.31%, with a small dip in the economy at -4.98%, and herd immunity achieved. The preventative measures used to achieve this are: travel restrictions set to the minimum of level 1, no restrictions on tourism, social distancing of 3.3 meters, 18 days quarantine period, testing 99% of the population, immediate contact tracing, no venue closures, and masks to be worn at all times. This video presentation shows how AI was used to develop AI. The final product is an app that accepts results of medical tests and predict if the patient will have a heart attack. An artificial neural network is used to classify the medical data into 3 categories: heart attack, OK, or borderline. To design an artificial neural network, the following parameters have to be determined: the number of layers, the number of neurons in each layer, the activation functions, the number of training epochs, and batch size. This can be a daunting task, and in the case of the heart prediction app, there are over 6 billion parameter combinations. Therefore, a type of genetic algorithm was used to find the optimum parameters.
Training a neural network is very computationally demanding. So 6 devices are connected to a cluster to allow 6 neural networks to be trained simultaneously. The panels on the left of the screen show the state of each device. The graphs next to the device panels show the progress of the neural network that is being trained on each device. The larger graph on the right shows the overall prediction accuracy thus far. The box in the bottom right displays the AI information and the parameters of the best neural network thus far. The video has been fast-forwarded to the end because it took several hours to train enough neural networks. 2,050 neural networks have been trained. The best neural network achieved an accuracy of 91.8% with the following parameters. 2 hidden layers. The first layer has 18 neurons and a linear activation function. The second layer has 13 neurons and an exponential activation function. The number of epochs used for training was 138. Conclusions: 91.8% is a very high degree of accuracy. Even if every 6 billion plus neural networks had been trained, 91.8% may not have been bettered. Notably, the time taken to train all 6 billion plus neural networks on the same 6-device cluster would take 2,400 years.
And here is the heart prediction app. The trained neural network with 91.8% accuracy can be used to predict heart attacks with the same inputs as the data that was used for training. "13 parameters such as age, cholesterol, ECG etc. are the inputs to an artificial neural network which has been trained to predict if a patient is likely to have a heart attack or not. There are 3 possible predictions: OK or heart attack or borderline.
AI can analyze a lot of data quickly to produce meaningful results. By tweaking various parameters, AI and simulators are useful to run what-if scenarios and experiments. The AI demonstrated in this presentation has many potential applications such as maths, science, electronics, engineering, computers, software, health, medicine, finance, and even the further development of AI itself. Thanks for watching. The end.